Taking another look at the new power supply. Good morning, YouTube. As you can see by the clock over in the corner, it is about 6 minutes after 9. Yeah, I just happened to see this in my pictures, and I thought, well, that'd be a good way to start out the day. I'm back here again today with the same type of video for a couple of reasons. I did make some updates to the design of the outer case as well as the circuitry, thanks to Jim Asbell. Jim was kind enough to point out my mistakes. You do these things, and you think, well, this will work. And yeah, sometimes they do, sometimes they don't. Well, in my case, I don't think it would have worked, because after I got to thinking about it, depending on how that filament was hooked up, I mean, if you decided to try and hook up a 6 volt and a 12 volt, it's possible that you could have grounded it out, the 12 volt, and that would have pretty much knocked out your whole meter and everything, because it depends on the 12 volts. It makes, the 12 volt is necessary for the operation of the power supply as far as the meter is concerned. So anyway, what I did, me and Bob, you all know Bob, we kind of put our heads together and come up with a new different plan for this. And let me go over to that real quick and show you. Now here is what it's going to look like. Now you can see the some changes there that have been made on the filament voltages over here. You have a common ground type plug here, and you have a 6.3 volt outlet and a 12.6. Just 3 of them. Now also you'll notice this ground symbol here, like this, is the same one that's over here. In fact, I just copied that and pasted it over there. The reason I'm doing that is because these two outlets, or whatever you want to call them, jacks, are common. In other words, they're wired together. And it's not because of the circuitry inside the power supply, but it's because of this. Jim was, he said he had a meter similar to this, and that the, in fact, the meter, the power for the meter was common with the output power, or actually the input. The output's a little bit different, but like I said, anyway, that is true. It is, and I noticed that, and that's why these are common. And with those common, that changes a whole lot of different things in here. And so what I came up with was this, and let me show you the circuit to go along with it, which I think you can see. Now you'll notice this is tied together here. These two filament windings are tied together to make a common bond here, and that is going to be our 6.3 outlet. And the 12 volt is the combination of the two. In other words, it comes in, we'll just follow it here. Comes in here, goes out here like this, around here, and here, and here. Okay, so that makes two 6.3 together in series. That makes 12. So that's what how that works. And here's our output for our high voltage over here. And you see there's that common ground symbol, and you'll see that's the same thing as here. And that's the way it works now with that meter in there, because I don't have the meter in here yet, but I'm going to add the power, the wiring for the meter. In fact, I can show you basically how it's done. Hang on just a second. Alright, well, what you're looking at now is the dual DC power supply. This is the same exact meter over here that I have for the new power supply. Now you'll notice here's our wiring goes like this. It comes the voltage from the source, in other words the power supply source, comes up here and goes through here, and is just basically a pass-through. This is just a sensing terminal. In other words, that just gives you your voltage, and here's your negative for that same thing coming in here. And now the negative that I'm talking about is common with this over here as these two here. This one here is common with this one here over that powers the meter. And now your output is coming. This green line is your negative output, and the way it's set up on this meter, that's how it measures the current from here to here. That's where you get your current measurement. So you got two different setups like that. That senses the voltage here, and this one here measures the current. So that's just the way it's set up. And like I said, these two are common. So that's where you get your common at, and once that meter is hooked up, that's where you get your common. Now, this one, I'm going to run a dedicated wire because I don't know how much, if ever that will even come into play, that common ground. But in case it does, I want to run a dedicated wire from here to here, because I don't want to have to depend on that little tiny wire inside the meter to carry any current. So, you know, if it's already established the fact that it's together, it needs to have a better wire, so where it will, you know, in case it is needed to be carry any current, that it will be there. So everything else I think is the same. Again, I just modified this section here, and now at the time, you know, if you're running your power supply over here and you're getting your voltage out, and you want to use these filament voltages, you should not have a problem with this common ground setup, because you can use either 12.6 by connecting here and here, or you can use the 6.3 by connecting here and here. So you should be able to use those at the same time also, because it shouldn't matter. The reason I went with this common ground, because if you look at most radios that use this type of transformer with a filament winding and a B plus type winding, they generally use a common chassis ground for both the filaments and the B plus. So there's your, you know, so if as long as it's going to be there, I mean, why not use it that way? So like I said, the meter makes it happen anyway. So. And also, I did eliminate the chassis ground over here and the 3-prong plug, so that's back to the way I'm going to be doing it now. So I am going to try today to take that dual DC type power supply. This is the meter wiring. It's complicated, let me tell you. But anyway, I'm going to try to take that over here and I don't need all this stuff here because there's only one power supply. The only reason I had all this is because there are two separate power supplies running in this one box, and I needed a way of separating the two so that the same meter or same supply is not supplying both. Now this one uses a separate wall wart to provide 6 volts coming in. Now it doesn't. It really shouldn't be any different than using the 12 volt. I mean, those meters will take anything up to 30 volts, no problem. So, anywho, that's what I'm going to do, or I'm going to try to do. So, like I said, you gotta kind of go back to this. So, I do plan to wire this up and test it, and try some different things to make sure that it is going to work. So. That's going to do me for this morning. I just wanted to put this up there and show you that I did do some changes, and thanks to Jim. Like I said, he put the bug in my ear and got me to thinking, and you do need to think once in a while when you do this stuff. So, all right, gonna get off here. Gotta go visit Mom later on today, and probably about 12:30 I'll leave. And you guys have a wonderful, wonderful day. Thanks for watching, and we will see you.